Today I'll explain you the features of Python programming. Now coming to the introduction of Python programming. Python is a high-level interpreted programming language known for its simplicity, readability, and versatility. Now one is high-level language where we write our code in normal English so that the people can understand the source code. And it is an interpreted programming language where we are converting our source code to the machine code directly. So we don't have any separate step for compiling our application. And Python is very simple to write, to read, to understand, because the syntax is very simple. We need not write any specific data types separately for declaring a variable type. It automatically takes whenever you insert a value. Now there is an indentation instead of blocks. In other programming language, we see blocks, flower braces, open brace, and close brace. We don't have that. And we have a readability concept. One thing is it's in normal English. We can just go for normal reading of the data where we can understand. And we can read some data from different applications like files and databases and some other modules. So it's very simple to read any type of data. And versatility. So versatile means here the ability to adapt for different tasks or applications to be performed. So here, since the Python is having very huge set of libraries, very huge set of inbuilt functions, so we can use this particular Python in automation, in scientific computing, in numerical computing, then go for data analysis, data pre-processing, machine learning. So you can see this Python has been working with a diverse set of fields. So that shows how the Python is a versatile language. Then who is the creator of the Python? So the creator of Python is Gudjovan Rossum and first released in 1991. And still thereon, slowly it has been developed. And around 2020 onwards, it has been taken a nice boom. And you can see very rapidly the particular programming language has been put into a diverse set of fields. Because it's very simple to understand, where you have a lot of built-in functions. So you need not write any sort of extra code for that. And that's the best part what the Python programming is having. Now, Python has become one of the most popular programming languages in the world, and it is used in web development, data analysis, artificial intelligence, scientific computing, automation, and many more fields. Now, coming to the features of Python, we have simple and easy to learn, then free and open source. It's a high-level language. It's interpreted language. Then it is a platform independent and portable. Then it is object-oriented. Then it is extensible. Then it is embeddable. Then it is extensive. Standard library it is holding. Then wide range of inbuilt functions. Then exceptional handling. Then memory allocation, robust, GUI programming, and many more. Now we'll see in detail one by one. Now the first one is simple and easy to learn. Now why do we say it is a very simple language and it's very easy to learn and understand? So Python emphasizes clear, concise syntax, and that is in the plain English, the normal English what we write and read. So making the code easy to read and understand. So the main thing, you need to be able to write the code and you need to read the code and understand. So that is the ultimate aim. So once you are thorough with the concept, understanding, and it is legible to read and can make your own code, then obviously that looks very simple. Now, Python avoids unnecessary complexities, allowing beginners to focus on core logic of the programs. So the syntax has also been very simple, where we don't write any semicolons for a statement. We don't write any flower braces. Instead of that, we do indentation. Then we do have built-in functions, basically not to do a major task. So actually, the beginners have also been feeling very much easy, and where they can focus on the core logic. So what is the ultimate aim? Why they are writing the programming there? They can focus. So instead of studying the bulky code. Now, unlike some other languages, Python does not require semicolons, as I was saying, because every statement, if you can see like C, C++, Java programming, then the .NET programming, where we used to terminate these statements, like the code, with a semicolon. But in Python, we don't terminate with the semicolons. Okay, Python does not require semicolon to the end of the lines of code. For this, it is simplifying the syntax. Because you forget a semicolon for any statement, then obviously you need to again come back and you need to check. So that problem is avoided. Then automatic indentation is available. So generally we used to keep the flower brace for any block. Maybe you write a for loop, you write a while loop, or you write if condition, elif conditions. So there we generally use the flower braces, if you can see the earlier programming languages. But here we don't work with any flower braces, but we have something called indentation. Indentation is nothing but a space. So if you take a full loop, for loop, you put a semicolon at the termination point. Then once you put a semicolon, then you get some space in the next line. So that space is called indentation. And lectional onwards, you're going to write in the same line. Okay, so that automatic indentation has also been available. So that's the best part of the Python programming. By this, we can say that the Python is very simple to understand. Now coming to the next feature, that is the Python is free, and it has also been the open source. So you can see Python is available for free download, because you have a lot of tools or the softwares for Python execution. Like you have IDLE editor, integrated development environment. Then you have the Anaconda software, where it is having some sort of integrated tools like Jupyter Notebook. Then you have Orange data visualization tool. Then you have RStudio. Now these sort of things which are available for data analysis. Then you have Collab, the online execution tool, where you can directly write your applications. Then you have the Spider. Then you have PyCharm. Those are all free to download. So we don't no need to pay any licensing fees for that. So this makes it accessible for personal, commercial, and educational use. And the source code for Python is open and accessible to the public. That's called open source. Now this means that anyone can view the code of the Python. Then you have the flexibility to modify the code and distribute the code. So that's why we say the Python is free and open source, where you can just download without paying any money, and we can use and we can modify or view the code. Now coming to the next one. Now Python is high-level language. Now Python is considered a high-level programming language because its syntax is similar to the normal English language, make it more readable for humans and less readable for computers. As we know, the computers doesn't understand your normal English. The computer understands only the binary format, that is zeros and ones. But in order to write one character, I need to write 8 bits of zeros and ones to define one character. But that is very hectic for a human to do that. We understand normal English, we write normal English, but internally the system is going to understand or convert it into the binary, and it is going to understand. So as per the humans, if we can consider, we need to see that any programming language to be understood and we can rewrite it properly. So the high level, the Python is in the normal English, so we can understand, we can read it, we can write it properly, the normal English. Then internally it gets converted into the binary format by the interpreter for the system generation code. Now coming to the next feature, we have interpreted. So as I said, the Python is interpreted language. So here the Python source code is converted into the bytecode, which is then executed by the Python virtual machine. So these all things have been internally done. We are not going to do any specific sort of compilation separately for the Python, because if you compare with Java, we write Java C and file.java for compiling externally. But here we don't require. The interpreter is going to take care how to compile and how to run. So in a single slot, we can just convert our source code to the machine code. Then immediate execution. Python commands can be typed and executed immediately. So you just type a command and it gets your code get interpreted and you get the output. So no explicit compilation option is available. So Python does not have any explicit compilation option. So as I said, for Java, we have Java C compiler. Here we don't have any specific sort of compiler where I can use and do only the interpreter is available, which is doing both. Now errors caught at runtime. Now because Python is an interpreted language, any errors are caught while the program is running. So only at the runtime only you are going to get any exceptions, because we don't have any the concept of the compilation. So in this, we call the Python is an interpreted language. Now coming to the next one, we have platform independent and portable. Now as we see, some other languages are also being platform independent. Similar to that, our Python has also been platform independent, where it can run its code on any operating system, and it is easily transferable from one system to the other system, or from one operating system to the other system, so that it can execute directly. So Python is considered platform independent and portable because it uses an interpreter that is available across different operating systems, meaning the same Python code can run on Windows, Linux, Mac OS, or other platforms without needing significant modifications, making it highly transferable between environments. So there is no need of changing your code. You can directly dump your code and you can execute your application in any operating system. It could be any operating system. Now that's the best advantage what you're getting. Because the interpreter is available for every operating system, then it can just easily convert into its equivalent machine code, and it can execute the application. So we are not going to worry that, okay, we are writing in Windows operating system and how could I need to make it compatible to Linux. Okay, so there are appropriate interpreters are available for different OS, and that interpreters are going to take care how to convert your source code into its equivalent machine code. Now coming to the next feature, it is object oriented. Now Python is object oriented language because it uses objects, classes, and other concepts to organize code and model real world entities. Now if you see the object oriented programming languages, we talk about classes, we talk about objects, we talk about the object-oriented concepts like encapsulation, inheritance, polymorphism. Now, class consists of the instance variables and methods. So here the classes are user-defined data types, because the class name we are going to define what should be the class name according to our application. So in that perception, we say it's a user-defined data types that serves as blueprint for the objects. Now, if you have a class, we can create the objects in order to access the methods and instance variables from that. Okay, so the class is holding the instance variables and methods, so it has been acting as a blueprint for the object. Then objects are instances of a class that contain data and have behaviors and attributes. So data is nothing but the instance variables, behaviors are nothing but your methods, and that implies functions, and it holds some parameters. So object is nothing but it's equivalent to a single record sort of thing. So if we have a student class, we can have a number of objects for that. Like suppose in a class 50 students are there, 50 objects I can create, so that every object is having the right to access the variables of a class and methods also. Now coming to the inheritance. classes can inherit properties from other class. So we go for superclass and subclass concept. So all the common functionalities you can keep in superclass, and subclass can derive the properties from the superclass to the subclass. And subclass is having the flexibility to have its own functions and variables also. Okay. Suppose you have a employee as a class, and I make as a superclass where the common attributes could be like employee ID, employee name, mobile number, email ID, address, gender. Now these are all common whether you go for permanent employee or ad hoc employee. So if you go for subclass, I can go for permanent employee where it holds all the features, and they can add few more attributes like HRA, then DA, then IT, income tax, this one. If you go for a ad hoc employee, we don't have all these attributes, but the common attributes we can derive. So like that, uh, that means in that situations we use inheritance. Then encapsulation is nothing but wrapping of the data and functions into a single unit. That is called as encapsulation. The best example is a class. Then polymorphism, the ability of doing a task in many ways, or the same entity can perform different functions in different scenarios. So we have something called function overloading. The method name is same, the parameters are different. So one method name I'm using, but through the parameters I'm able to perform different functionalities. So why to give different names? Okay, so there we use generally the polymorphism. So the collection of all these functionalities leads to the object-oriented programming language. So Python is supporting everything. So it is being considered as an object-oriented programming language. Now coming to the next one, we have extensible. Now, Python is an extensible programming language. So Python is an extensible language because it can be customized and optimized in a number of ways. One is write in other languages. So Python code can be written in other languages also, like in C or C++, and then compiled and run. Now, what is the advantage you're getting with this one is, this allows users to take advantage of existing libraries and modules from other ecosystems. So we are able to integrate a Python code into, or I can write some Python code with the help of the C programming language, and I can use the libraries existing in Python, and I can do my task in C programming. Now add low-level modules. So users can add low-level modules to the Python interpreter to customize and optimize their tools. So according to our requirement, I can just go for the utilization of the existing tools. So the lower-level modules can be integrated with the higher-level modules of the Python, and I can execute my applications for other extended functionalities. Now use of exec file function. So there is one function called execute file function, and it is used to extend Python applications. This allows developers to quickly locate and execute the relevant code for each command. So any point of time, any command you want to provide any additional functionality, so then I can go for using the execute file function in order to extend the Python application features. Now coming to the next feature, which is embeddable. Now does the Python code can be embedded into other applications? Because we are going with scientific computing, we are going for the numerical computing, then we can go for automation, then we can go for artificial intelligence. Okay, we are going for data analysis in some applications, right? So Python is considered embeddable because it can be integrated into other software applications as a scripting language or as part of an application's core functionality. So I can just integrate my code, the Python script, into a particular application so that I can do that particular task very easily. Because right from the scratch level, if you want to build any of the application, a time wasting process goes on because already one component is already built. So why you want to develop the same thing again? So why can't you write a small script and try to see that it is being embedded into the particular application so that your work is done? So that flexibility is available in Python. This capability makes Python highly versatile and valuable in a wide range of applications, from gaming, that is game engines, to scientific computing tools. So any application we can integrate this particular Python script. Now users can customize applications to their needs by writing scripts in Python. So that's what I was saying, that you have already some component. You want to just modify that component in order to make such customizations. There is no need of writing from the scratch level where you can waste your time. So you can just write a small script of Python and you can embed into that particular application so that your work is done. Now that flexibility has been available with the Python programming. Now coming to the next feature, extensive standard library. Now we have a lot of libraries available in Python programming and a lot of functions in the particular libraries. We have a lot of functions where it's already inbuilt, and just you can just call the particular function and your work is done. Okay, so the Python standard library supports a wide range of tasks, including like file input output, reading from and writing to the file. Suppose I want to create a new file, I want to write some data to the file, I can do it. I want to read some data which has been already stored in a file, I can do it. Okay, then data handling, we have some modules like CSV, JSON, and SQLite 3 in order to work with the data processing concepts. Then internet protocols, tools for working with HTTP, hypertext transfer protocol, then file transfer protocol, simple mail transfer protocol, and other protocols such as HTTP client, URL libraries, SMTP library. Now, these are all the modules which are already available in order to work with the internet protocols. Then data structures collections module is available where you can work with some concepts like stacks, queues. Okay, then linked list concepts you can work out. Then heap queues and more. So queue stacks. Now these are all comes under data structure, that also we can do. Then text processing, where string manipulation, regular expressions, and text formatting can be done. Then system operations like OS operating system interactions. We have some modules like OS sys module. Then we have we can work with some sub-process and multi-threading concept where we can run our application much more faster. So multi-threading, the best advantage is to execute your application parallelly so that you can increase the speed of the execution. Then built-in modules for mathematics, networking, concurrency, and testing, and other libraries like Pandas, NumPy, Matplotlib, Seaborn for data visualization and data pre-processing. Now coming to the next feature, we have wide range of inbuilt functions. Now that is the best advantage what you're getting with Python. Earlier we need to write a lot of code in order to do a small application, but now with one line of particular function calling, we are able to do a major work. So Python has a wide range of inbuilt functions because they simplify repetitive tasks and make it easier to perform common programming tasks. So huge code has been reduced. Now again and again I need to write the same set of code, maybe 50 lines, 100 lines, repetition. That particular task is gone. So we have some predefined functions which are called as inbuilt functions, are already available in Python interpreter. So you don't need to import a module to use them. So any point of translating your data into the machine code. So interpreter is there, interpreter is holding some lot of functions. Then you can use that. And you can reuse inbuilt functions within a program whenever needed. So you can call the functions multiple number of times. It's not like only one time or twice, no. Okay, you want 100 times, just call it only a single line sort of function. Your job is done. So the functions are reusable. Then versatile, inbuilt functions can perform a variety of tasks. So the functions like converting integers to strings, displaying some information. There are functions for modifying the text. There are functions for mathematical expressions, operations, then for handling input and output, for networking, okay, for machine learning, for data pre-processing, for data analysis, data visualization. A lot of libraries are there, a lot of inbuilt functions are existing in the particular libraries. So you can use that functions and you can do your task very easily. That is one of the best feature what we have. Now coming to the next one, we have exception handling. Now whenever any exception occurs, your program is going to be stopped. Now, that is called as an abnormal condition arises, then obviously a program is going to stop. Now here I want to handle that particular exception and I want to give a proper error messages. so that the client can understand and rectify themselves. So in order to build a proper error message, and your program also need not, that means once the exception is raised, I need to get some meaningful information why the particular program has stopped. So if you don't write exception handling also, the system is going to handle the exception, but that may not be understandable. So in order to overcome such problems, we do go for exception handling. So Python supports exception handling to help ensure that programs run smoothly by responding to unexpected errors. Exceptions are errors that occur during a program's execution and disrupt its normal execution. For example, dividing by 0. Any number by 0 is not possible. Then there's an exception there. Adding incompatible types. Suppose you want to store integers, but you are trying to store some strings, incompatible types, or trying to access a non-existent file. The file is not available. You are trying to open that particular file or read the data from the file. So these are few cases where the runtime exception arises. So we need to handle that, and we need to give a proper error message. So in order to overcome that, we do have some blocks, or we call it as suit here. So try suit. The try suit contains statement that can raise exceptions. So whichever code you are writing, you better put into the try suit or try block, so that it is going to detect line by line. It is going to check, and it is going to detect any exception is raising or not. If any exception is raised, that is given to the except block. The except suit contains statement that handle the exceptions, similar to a catch block. Here they are replaced with the word called except. Then we have else suit. It runs the code if no exceptions occur. The else suit is going to be executed if no exceptions are available. Then finally, suit is going to be executed even though you have an exception or not. So generally we write like closing of files or database connection closing, releasing of resources, such sort of code you need to put into the final block. And raise is a keyword used to throw an exception if an error condition occurs. That means if you want to manually throw an exception, you can go for the raise keyword. So these are a few blocks which is going to support for exception handling. Now there's also been available in Python. Now coming to the next feature, we have memory allocation. Now this is one of the most important aspects what we need to concentrate. So the memory allocation can be defined as allocating a block of space in a computer memory to a program. So when you define any variable and you are giving some value for that, like suppose x equal to 10, then we need to create some space over there. Okay, so based on the value what you are assigning, the system is going to identify how many number of bytes of space it need to allocate. Okay, so it is done automatically. Now in Python, memory allocation and deallocation method is automatic. Allocating as well as deallocating of memory is automatic. As the Python developers created a thing called garbage collector for Python, so that user does not have to do manual garbage collection. So for the developers, the headache is gone. Like allocating memory and deallocating memory for objects or the variables is gone. So automatically the memory is allocated whenever you declare a variable or creating an object, the memory get allocated. And once your work is over, you need not write any extra code for deallocating memory. Internally, the garbage collector is going to take care how to release the memory for unused objects. Garbage collection is an inbuilt feature in Python that automatically removes objects from memory that are no longer in use. This process helps to ensure that Python applications run smoothly and efficiently by preventing memory leaks and optimizing memory usage. If you compare with earlier program language C++, pointers are available where we work with memory addresses. There you allocate the memory, but we generally forget to deallocate the memory. We need to write extra code. So we generally forget that. Then the memory leakage occurs because the memory is wasted, the memory is stagnant. So that should not happen. So here that problem is avoided for the developers also, where there is no need of writing an extra code for deallocating the memory. So the memory leakage problem is gone. And here the best utilization of memory is also been done, which is nothing but optimizing memory usage, because objects which are not in use will be deleted and then the memory get free. Now coming to the next feature, we have robust. Now why Python programming is a robust language? Now we have a feature called stability. Applications built in Python are stable and less prone to the crashes. Now here Python programming has been supporting the task what we are expecting. So it's very simple to do the particular programming, and that particular programming is supporting in order to reach to the client expectation. Okay. And it has also been a backward compatibility where the previous versions of Python is also been supporting into the newer versions, and very quick releases are been also been done in the Python organization, that is the Python programming development. So all these things are been easily adaptable into the newer versions, and there is less error prone for the crashes of the system. So if there was incompatibility between the older and the newer versions, then obviously the crashes of particular application has been done. So coming to the second one, ease of debugging. So it's very easy to identify the errors and fix it, as well as it works with readable error messages and debugging tools. So there are some debugging tools existing in the Python, which has been supporting in order to identify and fix the errors, and it also generating some error messages which can be understood by the user. The reliability in production. Python applicants handled edge cases and unexpected situations gracefully, making them suitable for mission critical applications. So that if you go for the real-time applications, you need to go for validation properly. Sometimes you are expecting some phone number, you might give some other number. Now that is not a valid one. Suppose you're giving an email ID, you're expecting some email ID to enter, but you're giving some other string. That's also not valid. If you need to enter some currency, you're giving some other thing. So these sort of things you need to handle properly. So there is something called the boundaries for the inputs acceptance, or some other case where only that particular situations you need to handle. You cannot go beyond the boundary level. So your application need to be developed in such a way that what all the constraints have been putting, only that particular thing can be accepted. So we can develop some mission critical applications by using the Python. Then automatic memory management, already we have seen the memory allocation and deallocation has been done by the garbage collection process, where it is trying to avoid the memory leakages. So here the system or the application, the Python has been taking care how to work with the garbage collection, memory allocation, deallocation. So there is no need of worrying about the memory leakages. Now coming to the next feature, we have GUI, graphical user interface programming. So the Python supports graphical user interface programming. So we have Python GUI programming allow developers to create user-friendly desktop applications with interactive interfaces. So some window-based applications we can develop by using the Python GUI. We have something called toolkit interface, where we have some components, we call it as widgets, or the controls like buttons, labels, checkboxes, radio buttons, comp boxes. Now these things we can use in order to develop a desktop application. Then we have some frameworks like tkinter, PyQt, then Kiwi. Now they're all the modules which have been supporting for the beautiful GUI application development. Python GUI frameworks come with a wide range of widgets and controls to create interactive applications such as buttons, labels, checkboxes, radio buttons, text boxes, comp boxes, progress bars, menus, etc. Then GUI frameworks in Python support event-driven programming. So whenever you click a particular button, what action I need to do? Whenever you move the mouse, what action I need to do? Whenever you press the key, what action I need to do? Now these are all the event handling mechanisms. Now that has also been supporting by your Python. Then layout management, so where to place your components on screen. Suppose you want to follow some grid pattern, like two-dimensional rows and columns, you want to put your components, you go for grid layout. Then you have flow layout, where you can just put your components from left to right and top to bottom. Where you have tkinter is holding the place, pack, and grid layouts. So place implies where you need to give your own user different XY coordinates where you want to place your components. So like that, we do have some layout manager predefined, so that by using that I can place my components on screen. So these are few features, and the most important features I've been highlighting here. So if you can understand these features thoroughly, then obviously you come to know what is Python and what is how come that particular Python has become so powerful in very less time. So I hope I've given some input on Python features, the most important features. So if you like this video, do comment, subscribe, and share it with your friends. Thank you.